Hi everyone, I'm Mikayla. I'm the host of Hardware Meetup. We have only ever run this in Auckland, so this is our first out of Auckland one. So thank you so much for coming. Like, it's sold out, and that's really, really great to see. So even though we haven't run this here before, has anyone been to a Hardware Meetup before? Put up your hand. A couple.
Yes.
We even have some people that flew up here from Auckland just for the event, which is very cool. So if you haven't been here before, haven't heard of us really, we've been running since 2016, and we're all about bringing people together to showcase amazing companies working in different areas of the hardware space. So we couldn't run this event without our amazing sponsors. So first I'm going to hand it over to Steve.
Everyone, welcome to the Health Technology Centre here in the lovingly restored Arts Centre. So most of you will probably know, and if you don't, this whole Arts Centre complex used to be the University of Canterbury. We're now in the engineering school portion of the University of Canterbury. It was built in 1891. Around 50 metres to your right is where Lord Ernest Rutherford did his first nuclear physics experiments before he went away to pick up chairs in the lesser known universities of Manchester and Cambridge. And basically since then, obviously, there's been a lot of repairs, bring it up to the state here. So it's good to welcome you all here. And this is obviously, being the engineering school of such a beautiful building, this kind of spiritual place of hardware in Christchurch, I think. So it's a really good place for us to do our first hardware meetup here in Christchurch. So welcome.
I'm David Stokes. I'm based in Auckland, and I work from, there's a building there, an organisation called Outset Ventures. And so they're one of the sponsors for today. You've got their banner over there. But basically Outset, like this place, it's got a lot of history. So it used to be an old wool store, and Callahan's been in there, ESR's been in there, that sort of thing. But now there was a couple of companies like Landstech and Rocket Lab that started there, and really what's happened over time, it's continued to organically grow, and now we've got a whole bunch of companies that are working out of there now. So there's three things at Outset. There is space. So if a company wants to be able to set up fume hoods and workshops and all that sort of stuff, then it's the sort of place where you can do that. Yeah, it's a home of deep tech. So it is focused around hardware, around physical stuff, so not just software. The other side of it, they've got the ventures arm, so for companies that are looking for investment, particularly if they're in that sort of deep tech space, they've got a lot of speciality in that. And the third part, which we're sort of involved in, is around community. And so we've got quite a big community there, and run community events, people can come in and that sort of thing. So it's quite a magic environment. So yeah, if you're ever up in Auckland, just give us a yell, I can give you a bit of a tour.
Thank you. My name is Brent. I'm with GPC Electronics. We're a contract electronics manufacturer. We've got a factory here in Christchurch with about 70-ish people. We've also got a factory in Australia. And then if you're not in defence and aerospace, we've got a factory in China as well. We can do everything from 10 to 15 PCBAs every couple of months, up to complete box builds, cabinet units, and the like. Largest customer is an automotive customer in Mexico, and we're shipping about 3 million PCBAs a year to them. So quite a range of what we can do based on the factories.
Hi, we're a local company here in Christchurch. We build some of our own things, but also do a lot of development work, both hardware and software, for other businesses. It's hard to say what we do because we do a very wide variety of things. I'll just list a couple of recent projects in terms of what they are. AI-assisted medical ultrasound imaging device, pathogen detection using computer vision, electronic bird toy, a nanoparticle isolation device, and software and some robotics designed for biochemical experiments on the International Space Station. So a whole variety of stuff. We just like doing cool projects. So if you've got anything cool, have a chat.
Awesome, thank you. And our last sponsor is Dassault Systems.
So I'm Damien. I'm a local representative for Invenio. We're part of a Dassault Systems reseller. I look after the New Zealand team. We do not just software, but also hardware. So I'm going to take one of David's lines. So we supply tools such as SolidWorks, CATIA, Innovia, Delmia, through to additive technologies from Markforged. And as a business, we support a wide range of customers. And we have customers, some high-profile customers like Dawn Aerospace. They actually came up through a program here called our Startup Program, where we can provide tools for manufacturers of products at no charge or free. So, customers, new startups can actually get access to the right sort of technology to take their product to market. We have other high-profile customers such as Fish & Paykel Healthcare, Kia Aerospace, and then low-profile customers such as some guy that's making new road signs with lights on them to make them more visible. So we'll work with everybody. All of our members on our team are engineers, myself included. So we pride ourselves on actually working with our customers, not just trying to promote product, but rather get to know what you're doing. So please come and talk to me at the end.
So I'd like to really start with our vision as a business, because it's what is our North Star for what we're aiming for. It's how we navigate the business, it's how we partner with other people, and it's how we hire people. So we've all got an aligned vision. And for us, that's an electrified world powered by clean energy. So that's what we're shooting for. We know our needs for clean energy are going to explode over the next decade. So how do we manage that? And right now, I think we're probably not doing a great enough job of doing that. We know that. Mm-hmm. So let's do something about that. So this is probably your switchboard in your house right now. Like, you look at that. I mean, that's pretty old. You've got some 100-year-old technology in there. It provides the basis of, there's a bad pun there, basics of safety, and really nothing more. Like, installers are incentivised to do the lowest cost installation to meet the regulation standards, and nothing more. It certainly doesn't tell you about what the power usage in your house is. It's certainly not going to empower the change we need for this greener future that we have a vision for. We move on? Yeah. And like, we've all got smart meters right around the country now. Everyone's got a smart meter. They're really great at billing you. You'll get a bill on time every month. Bang, 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 bang. Really accurate. But it doesn't tell you where your power's going, right? And how are we going to change our behaviours if we don't know where it's going? Like, we're not empowered to do that. So we want to solve that. So moving along, we want to throw away this old way of doing things. Just throw it away, put a big X through it. And we've invented this idea of a smart panel. So a smart panel for us is building on what you get with your existing switchboard, but adding in the insights that enable that change, and lifting safety as well, so we can make these houses just safer to live in. Can you move forward? I need a
Just do a
command.
hand signal, yeah.
Yeah. So our smart panels, they replace your current switchboard. They get installed into your house, become a fabric, part of the fabric of your building that you're living in. And they provide the safety. They've got sensors that provide the insights. You get an app for electricians so they can configure it, change the settings of your house, add new features. You've got a consumer app. That's where you get the insights for, where your hot water goes, etc. Empowers that change. And I think we should also acknowledge the electricity industry. They're just as blind as everyone else. Your retailer, they don't know where your power goes. They don't know how to provide you with a retail plan that actually suits your needs. They have no idea. What if they could make a plan that, for instance, gave you free lights in winter so you didn't have to be in the dark and made that cheaper? That'd be cool. Or, sponsor your grandmother for heating in the winter. What about that? That'd be cool. We can't do that right now. The distribution companies, they don't know where the power goes. Sometimes they don't even know which cable connects to which house. So everyone in the industry is blind. So how do we actually enable change through just leveraging the data we're going to have?
Mm-hmm. So how do you make these smart switchboards? Yeah.
Great question.
This was not planned.
And one more, please. Yeah. So, interesting thing about the smart panel, like, it can tell you, where is your power going? Is it your hot water, or is it your hair dryer, is it, your clothes dryer? It can provide the safety, but it can't do any of that unless it's installed in your house. And that's the first barrier for adoption, is actually getting these into houses. Like, why would someone install it, right? So for us, we'll get better by number 3. So we've got to make life easier for electricians, right? They're the ones that install these in your houses. So we've really worked with them along the way to make sure that they can install these seamlessly. We've looked after them. And what's fascinating is you can't actually buy a switchboard right now, right? Like you can only buy all the bits for making a switchboard. And a Sparky, they'll turn up to your house with a big bag of bits and pieces, and they'll bespoke build one for every house. And that's because every house is different, right? So some people have got, multiple air pump, air conditioning units. Some people have got a spa pool, or electric hobs, or more than one of those. And because of that, we make them bespoke for every house. And when you think about it, that's actually a little bit stupid, isn't it? Like, why? It's quite antiquated. So we've worked out how to build them in the factory. And just use an app to configure them, which seems sensible to us in hindsight. So, moving along. What that has done is that has made life easier for the electricians by making the installation easier and rapidly faster. So installing a traditional switchboard will take sort of 3 to 6 or maybe even 8 hours, often a couple of people. Our target is under 30 minutes to get in, switchboard on the wall, click, 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 configure, out of there. For a Sparky, that means they can get on to the next job. They can do more installs per day, and they can come back, and it's just an easier way of working for them. So that's an astounding change, and we're going to move beyond that, have moved beyond that. It's just little things like, right now, a Sparky, when they install the house, they get the wires, they've got screw terminals, they've got a screwdriver, they do up the screws. If they don't do them up tight enough, right, they get hot, right? They get hot, you get meltdowns of switchboards, you get fires. Just go Google melted switchboards. It's quite amazing, actually. It's a common cause of failure. And it's like, well, why do we have screw terminals? Why not go just little spring levers, same pressure every time, and it's faster to install. Like little things like that. Little things like actually grouping phase neutral and earth connectors side by side. They come in the wire side by side, so why do they have to go all over the place on a switchboard? It doesn't make sense. So, all these little things make it easier, such that like a trainee Sparky, apprentice, first day, they could install a switchboard. Can't do that currently. Yep. So again, making life easier is actually a big part of that. Should we go a little bit deeper, eh? We added some cool e-ink displays. Ooh. Can you see that? So these actually preserve the information. If there's a power outage, you can still see, hey, look, settings are like this. And we've even annotated, you got solar, there's your oven. So that's configured by the Sparky. It shows up on here. It meets with regulations, which is really cool. And it looks cool. So we like to have a good, nice, pretty design. And it's a hardware meetup, right? So let's talk a little bit about hardware. This here on the left here, that's a existing state-of-the-art miniature circuit breaker. It's a collection of springs and levers and bits of metal that bend when they get hot. And that's what protects your house right now. You can buy them for $1 out of China from the factory, which is quite crazy when you think, what else do you buy for $1 that you protect your important assets or your children? That's quite staggering. So we've converted that into sensors and software that can not only do all of the sensing, do the algorithms, do the processing, work out if it's safe, but also do redundancy and fail-safe type operations, which is better, right? So that's pretty cool. There's a lot of maths going on inside there. And we have a block diagram because it's a hardware meetup, right? There's lots of engineers here. I'm being a bit cheeky with that, but we have a block diagram. So right now, in your house, your protection is operated by their sensors. If they go over a limit, like too many amps, TRIPS provides a very basic safety function. By adding the microcontroller in there and the software, we can make that configurable. So now we can put configuration in, and we can adjust it per house. Maybe this oven is 32 amps, maybe this one's 20. So you can get the configuration in. But also, you can bleed off the data. Then you put some algorithms around your data, and you can provide those insights that we need for change. So we get that as like a double whammy, so you can do more with that. And at the end of the day, like that additional data is actually what provides insights that is going to empower the change that we're looking for.
Awesome. What would you say the journey has looked like so far?
Quite long. Quite long. Probably another.
Oh.
Yeah, so we are 4 years in. It's been quite the journey. We started during the pandemic.
That's a bit rough.
So, yeah, the two founders raised the initial convertible note for $1 million at the start of the pandemic. They gave me a call. I was just working in my bedroom at home, actually with one of the people in the room today. And they're like, hey, is this feasible? It's like, I don't know, let's go find out. So we did that, and then we raised a Series A, and that's what's enabled us to go and build our first prototypes, get those into houses. So we installed a number of units in houses in New Zealand as a compliant certified product. That was a huge milestone for us to get that in place. Pretty cool. And where we are now is we need to get that to scale production, and that's coming soon. We've got Q1 next year marked on there. So game on. We need that to stay afloat. You'll see we've also grown to 90 plus people, which is quite staggering for a startup, but we're pre-revenue, so it's okay, isn't it? I think the point to call out here is hardware is hard, right? Everyone here probably knows this in the room. And what's really important is that you understand your product market fit, right? And you understand who your influencers are in the market, because it's going to be a long, hard journey to get your product out there. I think we all know this, right? You need to be able to build strong relationships with your customers, iterate, learn, and most importantly, how do you keep the money flowing into your business? You've got to have those investors on board, and they're going to look for that product market fit in the story that you tell around that. It's quite important. For us, we know electricians, they're our influencer. They do everything for an install in a house, and it's important that we look after them, that we understand them and support them in our journey. So, right from the early days at the start of our journey, we built a lot of really ugly prototypes. I tried to find the cardboard one we made. I couldn't find the picture, but we know that's ugly, right? But it was fast, and we could go to the Sparkies, we could test installs, and we did so many just iterations, learning what the pain points are, learning how to work with people, how to make the workflows faster and easier. And we built a lot of really strong relationships with our initial customers doing that, which was enduring today. We've had a huge focus. I think we missed a slide along the way. Maybe not. Oh, okay, that's all right. We've had a huge focus on team. Like, it's hard doing what we do. Like, it's high tech, it's deep tech, as the chap said. You need to get really good people, and you need to retain those people as well, right? You don't want to hire the same people twice, right, or hire the role twice. So getting those people on board and looking after them, building a culture, and going back to our vision, having that vision allows you to hire people that share the journey that you're going on. It's quite important. Click. It's going to be a bit ridiculous, but we built our own compliance lab, like an internationally accredited compliance lab. And here's the thing is, if you're in hardware and you need to have a compliance certificate, and for us it's not just that, but you need a government-aligned agency to even sign off your compliance certificate is okay before it's illegal to install your product. You build your hardware, you go through the factory, it gets made, it goes into a compliance lab. If you miss this slot you've booked in an external compliance lab that you booked 6 months out, like, what do you do? Like, you're a startup, you're funded, you're dead, right? And if you go through that compliance and you fail, you got to book another slot 6 months out. You're dead. And we saw that and we went, oh my gosh, we need our own lab because we just can't survive otherwise. And it was expensive, but it's doable. So for a startup, you can actually make your own compliance lab. It's been a hell of a journey. We've learnt a lot about it, spent a lot of money on it. But that means we can automate our design and development and production cycle now. It's going to be more like a factory than anything else. So it's going to be really amazing
So
to
you can kind of like
have that.
fail fast, right? Like
Yeah.
that kind of way, yeah.
Yeah, fail fast, learn fast. And it's not just if your product fails, but even how do you do testing? If you have a novel product, like you might not even know how to test. We didn't know how to test it. It's so new, no one knows how to test it. We've had to make stuff up along the way. And having a lab that you can work with just streamlines that.
Yep.
So I guess that just recapping our journey is, that seed round let us do the feasibility, lock that away, use that to raise, a fairly significant Series A. We've completed installs in houses, and right now we're looking to roll out our production units and, scale up after that. Won't be a startup anymore, we'll be scale up.
Oh. So yeah, what are you pushing towards then in that direction, I assume?
Yeah, so slide I prepared earlier.
I need to get the clicker fixed.
Yeah, so our mission is to have one of these in every house, every building, right? And that sounds ridiculous, right? That sounds ridiculous. But if we're going to affect change, the kind of change we want to do with our vision, we've got to have big, audacious goals. Like, think big. We unashamedly want to be a unicorn, and that's what we're going to push for. So
That's a good aspiration.
game on, right? Let's think big. And just coming back to our vision, we see this world powered by clean energy. So our future is building more partnerships with like-minded companies, right? And we're going to do more than just, switchboards. We're going to do other activities that are aligned with that. So how do we do energy management such that we have clean energy going forward? And who should we work with and who should we not work with? So that's our future.
Awesome. And do you have anything, any help thing the audience can help you with today?
Yeah. I think we need to recognise we're all part of this high-tech ecosystem, right? And as a company, we've benefited from everyone else existing here, and there's some contractors to basis in this room. We've relied on the expertise, we've relied on the skills, the infrastructure. It's all lifted us forward, and in return, we're starting to help them grow as well. And if we're going to be a successful country, right, we're going to grow New Zealand's tech ecosystem, we've got to be helping each other do that. And I just encourage everyone to work together to support us. And that's all on the next slide. But maybe a bi-panel. And but it's we benefit from the ecosystem, and we're quite keen to support that going forward.
Awesome. Cool. Thank you very much for telling us all about Basis, Brendon. And now we will open to Q&A. Send in your questions, please, and upvote questions, because since we've been running a bit behind, I'll probably limit this to 10 minutes. It's not pitch time yet.
We're running ahead of time.
So where do you like it?
Jana. Yeah, we're looking to grow to be a large company, making hundreds of thousands or more units. The only viable. Yeah, in China. Yeah. That's the only place we can get the scale that we need.
We really haven't had any technical difficulties in our last 5 events.
Steve.
So it looks like you're going to save a lot of time for electricians. A lot of electricians I know bill by the hour. So does that mean electricians are going to have to change their revenue model?
Yep. And they're on board with that, right? They get some efficiencies. And if we can shift some of that from time-based to actual product-based, it's better for them. There's the current MCBs and the existing switchboards are cutthroat. There's no money in there. We're offering an opportunity to partner with us to come back and do maintenance, and we're doing lots of interesting things around that space, around being able to notify a Sparky when your panel has a fault, rather than waiting for the homeowner to work it out, get in touch. So how do you streamline that workflow for them so they can get ongoing work as well?
Will they be sort of authorised, like basis affiliated?
Yeah, absolutely. Yeah, initially at least. Once we dominate, it'll just be the status quo, right?
Awesome, thanks, Steve. Okay, our top voted question: how do you ensure that a homeowner can have a service life of your system of 20 years, especially with the app?
Yeah, absolutely. So, the app's quite easy to upgrade. We have a reliability program in place for the life of the switchboard, and we've got a reliability team now, and we've got a whole bunch of thermal chambers in town here in Christchurch running 24/7 testing our product. It's important if you're going to make hardware that it's reliable, and consumer expectations for electrical switchgear in a house is they last a really long time. So we take it seriously. We don't want to be, like a recall would just kill us, right? We know that.
Why would the existing homeowner change to this rather than their existing switchboard?
Yeah, numerous reasons actually. Hopefully they care about the future, and want to better manage the electricity, or they want a cheaper bill. We can provide insights that lower their bill, or there's all sorts of other reasons why we can provide greater safety. Now, a simple example, right? If you have a childcare centre, you send your kids to childcare. The law mandates that they have a lower threshold on residual current device detection, right? Because children are smaller, they get electrocuted easier, okay? But those lower ratings don't get put into houses, right? But hang on, children live in houses as well. So you're like, well, that doesn't make sense. Why are the children less safe at home than they are in preschool? So we added the capability that you can just turn it down. Just, cool, kid's bedroom, make it safer. It seems like a no-brainer when you think about it.
Awesome. How well does this work alongside solar and battery backup systems? Can you control what is going where and when?
Yeah, great question. We are solar and EV ready, and you could support simple battery, but we don't have a lot of battery integration just yet. But coming, like a startup, we need to prioritise what we're doing. So out of the box, you can plug your EV in through our switchboard, and we can do load management and time shifting of loads as well. So let's say you want to control when your hot water turns on, because you want it to be when it's middle of the day or whatever, then you can just do that with the app and set a timer. Boom, done. So awesome.
Sparky now has 1/4 of their revenue for the same job. What would the Sparky's uptake on your product if that is your channel to market?
Yeah, so we've got a 100% ENPS score with Sparkies. They're totally on board with our product.
What does that mean? What ENPS?
That's it. We survey Sparkies and how they feel about this, and they love it.
Cool, awesome.
Yeah.
What are your safeguards you've built around data? Have you experienced any private interest in your collected data from power companies or local councils? That's a good question.
Yeah, so there's a few things in there, isn't there? Can I read that? No, it's gone. Whoop, too late. I'll make it up. Yeah, so we have a lot of data, right? We have, of course, privacy policies, and we take data and data security quite seriously. And more so than just consumer data, but there's some pretty significant impacts from having a unsecure electrical grid within the country. So the data is available to users. It's effectively owned by users. You have all the rights that you would with any other data to store and delete as you wish. The other part of the question was, remind me.
Oh, I think if anyone has exhibited interest in it, I guess like
Yeah,
councils
absolutely.
or
As I
power
mentioned
companies.
before, like power companies don't know where your power goes. So we need to work out how to, in a clearly anonymised way, highlight to them where the opportunities are for change. Like, it can't be a model where we're like, this is what I do and this is what I do.
Mm-hmm.
How do we collectively work together to actually solve this? Like, how do we make up new models of distribution and consumer pricing plans that incentivise everyone to change their behaviour? How do we offset some of the costs of infrastructure spend on the grid to upgrade the grid for all our EVs and actually just time shift that so that it just goes away? So if we can do that, we can actually lower the price of electricity for everyone. Like, it's a winner. Might have to share some data, lower bills.
Are there any questions online, David? Oh, they're coming through as well. Oh, perfect. Okay. Last question, maybe last two questions, so vote. Does a homeowner need an electrician if they want to move, e.g. their washing machine? Like, I guess, is that like realigning the switchboard? Like, if they want to move their washing machine to a different...
Yeah, because it's plugged into a socket. They move it to a different socket.
Yeah.
The socket.
No, because that socket will be labelled laundry, so that's totally fine. But the homeowner can't do other prescribed work, of course. Electricians have to install a panel, but there's no other changes within a house in terms of how you plug things in and unplug things.
Can you reassign the washing machine to an outlet that's in your bedroom on your app?
Yeah, so your bedroom would be bedroom and your laundry. I don't think we'd go as far as putting washing machine on a circuit label. Not yet. You watch for the future.
Okay, last question. With an existing switchboard, you can replace a single switch rather than the whole unit. Is that also possible with this system?
Yes, that's a short answer. There's really no differences to downstream wiring. It's just like it has been before. We're just replacing the switchboard. You can do anything downstream. We don't have any data cabling going to switches or other downstream parts of the house wiring.
Awesome. So thank you very much for joining us and sharing all about what you guys are doing.
Yeah, thanks for the opportunity.
Thank you.
It's been awesome.
Thank you very much, Daniel, for joining me. So could you tell me a bit about what Syft does?
Yeah, so I mean, I see a lot of people around the room who I'm not telling a news story to because they've worked with us in various places in the past. But I mean, for some of the other of you, you may not have heard of Syft. Syft is a company that produces scientific instrumentation that basically measures tiny, tiny, tiny amounts of chemicals in air. And we go out and turn that into data so that people who are trying to do things with the environment, with semiconductor, with a whole lot of other things, can make better decisions about their process because they've got more information. So like we're basically, we went out to, we've ended up building the hardware that we need to do this because we want to build the applications, we want to help people with this stuff, but no one else was going to build the hardware. So it's a company that in a lot of ways has had a technology that's going out and looking for a solution. And I'll tell you a little bit about some of the little solutions we've glommed on to a core technology change as we've gone along. But to give you a little bit more information about Syft, it was founded in 2002, spun out of a University of Canterbury research group. So I'm one of the super, super lucky people who gets to still be working on what I did in my PhD 20 years later. And I've been someone who's taken, when I started on it, it was a research idea, absolutely no practical application for it. And I've been able to take it all the way through to being out in fabs, in semiconductor fabrication facilities, in Samsung and Micron and all of these places that are just absolutely leading the world. And we've been able to support them with that. So that's so cool. We're one of the leaders in semiconductor AMC monitoring. AMC stands for Airborne Molecular Contaminants. Basically, it just means what happens when you contaminate things with the tiny amounts of chemicals that cause them problems. We also do environmental monitoring, so telling people what chemicals and toxics are in their air. We've done container safety analysis, so every shipping container that's opened by Canadian Border Security, by Australian Border Security, checked by one of our machines first to make sure that the people going into those containers don't get killed by the chemicals in there. We're also just been working on taking this to pharmaceutical analysis. So the last wee while has been doing high volume pharmaceutical testing and dealing with all of the intricacies of 21 CFR Part 11 and the fun things like that. We're based worldwide. We sell very little in New Zealand. Huge install in South Korea and across Asia. Big installs in North America and Canada and across Europe as well. Yeah, $20 million US revenue, that sort of number.
So can you tell me, how do you make these products?
So I thought I'd start with telling you a little bit about what they are and how they turn into products. So if you start at the top of this slide, you're sort of where the customer is. So the top layer here is what we call our solution products. So that's where we've taken our core technology that's down the bottom, turned it into a specific type of analyzer, and then mated it with a bunch of accessories and some analytical chemistry. So Syft has hardware people, software people, and scientists all working together to produce a solution that is basically just a data stream that people can then interact with. I'll tell you a little bit about how it works, because that's kind of interesting when you get into the hardware side of things too. So what we do is called a mass spectrometer. A mass spectrometer basically measures the mass of chemicals. In order to measure the mass of the thing, we need to put a charge on it so we can move it around with electric fields. That's why what we look at, and sometimes when we're talking about it, we say Syft is a unique combination of mass spectrometry and ion chemistry. Mass spectrometry's been out in the analytical world for years. Trying to treat it as an ion chemical reaction is something that's unique to Syft. And so you suck your gas into there, you run these ions at it, you have a reaction, that's where the chemistry comes in. And I'll apologise, I'm not an engineer, I'm a chemist originally, but I've spent most of my career building instrumentation, so I occasionally somewhat tolerably fake being an engineer. I see people laughing when the somewhat tolerably part. And then we're able to detect those. So in terms of the hardware sides of things, this requires you to have a huge amount of mechanical design. We've got high vacuum pumps, we've got gas flows to manage, we have electronics that need to generate high voltages, RF fields, we've got pulse counting, data analysis, all of that sort of stuff, and it's all pretty much built in-house in Christchurch, because we do a unique combination of it. We can get little bits of the components off the shelf, but we're the only people who stick it together that way. So in terms of the sticking it together, that happens at our production facility in Christchurch. It's about 4 blocks that way. It takes me about 5 minutes to walk here. We're just in front of Basis and now just behind Mars Bioimaging as well. So there's a nice cluster of tech firms in that space now. We have a big clean room facility there. Because what we're doing is building high vacuum equipment, any sort of dust or chemical contamination getting in there causes us problems. So we've ended up building our own, getting our own ISO 7 clean room in there, and it made a huge improvement to our ability to reproducibly build these things. So in terms of how they're built, it's all designed in New Zealand, and then the subcomponents are either bought from overseas or shipped out to be manufactured overseas. They come here and we do all of the assembly, and then the tuning and the analytical chemistry and the software and stuff that goes on top of it here in New Zealand. So that's kind of what we do to build the product up. It's pretty nice in that we've got that really sort of big range of people working on it. So you've got a lot of different skills, and the opposite side of that is it's a big challenge to get all of these different disciplines working together to come and produce these things that are essentially just data generation. And when you get out in the field, your customers are only looking at your quality of data. So there's a lot of trying to work out what happens at the data level, then tying that to what's happened somewhere else, then working out how you go back through the stream to develop the right little subcomponent that controls this little bit better so that the previous 1% wiggle in your data goes down to 0.75%. In terms of, like, when I'm talking about the data, our limits of detection, at the moment, the best we're doing, I think the best chemical is probably doing about 10 parts per trillion in less than a minute. So a part per trillion is 1 part in 10 to the 9, so that's 1 part in 10 to the 8 that we're measuring. We measure that with a precision of like 20 to 30% accuracy, and that's what we're doing in real time for people. So when we're talking about the semiconductor fabs, they are 24/7 monitoring that. They're trying to work out exactly what's happening when and make decisions on top of that.
What does the journey look like so far?
So I started with picture, and it's a little bit sarcastic and tongue-in-cheek, but it's basically to say, look, this started out as something that was as unapplied as you could possibly get. In the 1970s, people realised that that there was iron molecule chemistry going on in the upper atmosphere. They flew what are called sounding rockets up through the ionosphere, and they suddenly realised, hey, it isn't just oxygen atoms being turned into oxygen ions and nitrogen atoms being turned into nitrogen ions. There's all this chemistry going on. And so they wanted to build this equipment just to measure the chemistry. So like when I started my PhD, it was, I was a kineticist. What I was trying to do was work out how fast different reactions went. And someone realized, hey, if I flip this backwards, if I know how fast the reaction's going, I can work out how much of the chemical it is. This happened in the UK with a research group that was very, very closely aligned to the research group I was working in the University of Canterbury. So the first publication of that was in 1995, and in early 1996 we had them down here to New Zealand, and we turned our instrument into it, and that really started things. So my PhD that started out going, I'm going to measure how fast iron molecule reactions go for the ionosphere of Titan so that I can model the data that comes back from the Cassini-Huygens probe, turned into, hey, maybe I can work out what happens to people's breath when they run up and down stairs for a while, or what happens to the air above soil when we add fake sheep urine to it. So it was a bit of a diverse PhD, but like that was what created the idea that this could be an analytical technology. The analytical technology had some unique characteristics, one of which was that it was really good at working in high moisture environments. As I mentioned earlier, people were looking at breath stuff with it. That's a high moisture environment. Like when you breathe out, there's a lot of liquid and there's a lot of water in there. It'll turn to liquid if you breathe onto something cold, but it just stays in the gas phase if you don't. And for a lot of analytical technologies, that's a problem. It wasn't a problem for Syft, so we started to go out, okay, can we turn this into a company that will help people understand what their health is doing, and we can measure the chemicals that are in their breath. So we started in 1995 with the technology invented. In 2001, while I was overseas doing my postdoc, the founding professor of Syft went out and started with a couple of other academics in Christchurch to create some interest in a company that would maybe like measure what chemicals are in people's breath and try and tell them how that might help their health. There was enough interest to do that, and we started to try and take what was a huge piece of university equipment. The equipment I was working on was about 5 metres long. It weighed somewhere in the up around 2 tonnes by the time you counted the pumps and things in it. It wasn't exactly going to be useful for anything in the commercial world. We started to turn that into something that was actually usable commercially. Now, as you'll have noticed, I haven't mentioned breath analysis at all previous to this, and that's because relatively early on, we got an academic in Australia who'd been contracted by the Australian Border Security people to go, hey, we've got this problem. We need to detect all of these different chemicals that are in shipping containers. In shipping containers, you have to fumigate them so that environmental biosecurity risks don't move across borders, but they're also there's all sorts of chemicals in every product you buy. And a lot of stuff is stuck in a container only kind of half-baked, and all of those VOCs, all of the paint, all of the glues, everything like that pours out into this contained environment. People have been seriously injured, and in this case that there was some interest in Australia to try and solve this problem. So they came along, and the founding professor and this guy were talking, and he came back to Syft and said, hey, I think I have a problem that we might be able to solve. And I think I have a problem that we might be able to solve is kind of the arc of Syft in terms of product market fit. There's this lovely straight line here that says we had this big instrument, we turned it into a smaller instrument, we made it more capable, we turned it into a smaller instrument, we made it more capable. But the actual story goes, it's all right. We started off at breath analysis. No one really wanted to buy it because it didn't make sense economically. We found a problem that no one else could solve, even though it was really big and expensive. No one else could solve it, so they wanted to buy it. And then on the back of that, you keep going and going and going. I think Syft, in a lot of ways, has been a bit of a double-humped startup. We started in 2002. We were just starting to ramp up. 2008, 2009, things got pretty bad for a bunch of people. We went back into hibernation mode, but we had a couple of core customers that we were serving super well. We were solving their problems. We were making their lives easier. Like in the container safety, to do the same analysis that we were doing in 2 minutes was taking people an hour and a quarter, and it was costing them $400, and we were charging them like 50 cents of consumables. They paid back a multi-$100,000 instrument in less than a year. Kind of makes sense, so we'll keep doing it. Then we were able to find these other spaces, environmental. Like we knew that we measured chemicals in air really well. Measuring environmental analysis is really good. So we've now got instruments out with the US Environmental Protection Agency. They put one of ours in a van, and they drive around to sites. In South Korea, there are 60 of these instruments based in these vans in the back of these mobile vans, and each of those vans has an area of a South Korean city that they are responsible for the air quality of. They drive around and they go, oh, the levels are going up, I should turn this way. The levels are going up, I should turn this way. I get to a point, I go, it's this chemical. I look it up in their list of who's using what chemicals. It's above the level, that person's using that chemical, I go give them a ticket. Again, it makes sense economically because they can do what they want to do, and no one else was able to do it. In the food and flavour and fragrance, we've been able to solve people trying to understand what smells come off your food. So you can stick a tube up the back of someone's nose and you can sample the retronasal space, which is about as comfortable as it sounds, and look at what chemicals are there. And it tells you, you can bite into something and you see the chemical go up. The people who make food want to know whether this one tastes better than this one and why it does. So that's an analytical technique. The big thing that we've been doing for the last sort of 6 to 7 years is semiconductor fabrication facility monitoring. So you've got the silicon wafers, they're inside a really high-tech piece of equipment that's engraving the various transistors on them, right? And they have to control that to amazingly precise levels. But then to move it to the next piece of equipment, they have to take it out of that, put it into a little robot that runs around the ceiling, and then put it into the next thing. And every time they do that, it gets exposed to the chemicals that are in the air in that facility. Now, that air has to be there because you need to have the people in there. You can't run a completely clean nitrogen-filled fabrication facility because it's not really possible for your to put all your workers in breathing apparatus all the time. But every time you've got people in there, you've got processes in there, you've got chemicals. And half of those chemicals are the things that are trying to etch the wafers in another place, so they're causing damage to the wafer if it happens unintendedly. So we've started to monitor there. They use us to understand what happens when this door is opened, what happens when this process goes on, what happens when they start to get a leak in some gas supply system, how that affects the yield of the wafers turns into the economic benefit for doing it. Like our equipment's a multi-$100,000 piece of equipment, but for them, when you've got a single, what they call FOUP, front opening unified pod, which is a thing that carries 8 to 16 silicon wafers, that could be $200,000 worth of wafer in there. Like, you don't have to save them many problems for it to make money come back.
There's so many different applications. That's so cool.
Yeah.
Could you tell me, so that was the journey. So what's the future shaping up to look like then?
So I think there's two answers to that. There's kind of a technical answer to what the future looks like, and that's really a continuation of that curve. And that's we've got to make it smaller, we've got to make it cheaper, and we've got to take it from parts per trillion down to parts per quadrillion, and we've got to make it go from 1 minute to 1 second. Like, there's a bunch of engineering and all the sorts of challenges in that. But the other part of the challenge is probably also in this, and that's that we're a company that's been around for 20 years. I mean, we've done 2 humps in startup, so there's a bit of a middle in there that gets us a little bit more grace, but we've very much moved beyond that place where we've gone through startup, we've gone through scale up, we now kind of understand a little bit what our market size looks like and how we're going to do it. So it's finding that way to keep pushing forward, keep developing it, because if we don't, we're going to be beaten by other people and we're going to be irrelevant, but also make that work so that we've got a self-sustaining economic engine that sits in behind it. So there's the engineering challenge and there's the organisational challenge, and those are the two things that the next couple of years looks like. The pharmaceutical stuff is a huge thing for us, where we just launched that the early part of this year. So we're going through that early adopter phase at the moment with that. We've had to deal with all of the compliance in terms of 21 CFR Part 11, data provenance, etc. And so that's an immediate challenge on us, but yeah, the medium and longer term challenge is that continue innovation while being sustainable from an economic sense.
And last of all, is there anything you need from the audience today?
Look, I had to think about this, and I don't think there is a whole lot I can say. I will, in a lot of ways, echo what Brendon said. I think even more true for Syft, because we are so outwardly focused and because we're, in a lot of ways, a science company, I think the interrelations between Syft and all of the hardware people have not been as good as they should be. So I think, yeah, one of the things I'm looking for is to build some more community and let us let us know where we can help you. We've done a lot of things, we've made a lot of mistakes. Someone should learn from it.
Awesome. Well, that's what we're here for, to help build a community. So hopefully we can do that here in Christchurch. Awesome. Thank you so much for telling us all about Syft. We're now going to open the floor to questions. So please submit, please vote. So first up, why isn't TSMC a customer? Do they have an equivalent tech? I don't know who that is.
So TSMC is a Taiwan Semiconductor Manufacturing Corporation. TSMC are the manufacturers of a lot of the chips that run AI at the moment. So they're one of those things that, like 5 years ago, very few people would have heard of them, and now they're a sort of a semi-household name in the right place. Why aren't they a customer? There's a couple of reasons. One of which is that they take a very different approach to how they control things. TSMC are very much we know what we do and we do it very well. We don't want people telling us what we don't know. If that makes any sense. That they are still working with what we'd call legacy tech. So they have ways of doing it, but not many of them are real time the way we would do. Mm-hmm. It's a space. The other thing is that their value of their chips is significantly higher. So for us, they're not as economically viable a customer. We tend to aim at the memory space rather than the foundry space. And so, yeah, nuances in there. Happy to talk a lot more about that if someone wants to go, but that's the short version.
Mm-hmm. What was the most exciting thing that's happened at Syft over the years?
I can probably. I think it's for me exciting and validating is a lot of the being able to solve problems for people. Having it be as widely uptaked across places like the container safety application, like the semiconductor, those are pretty interesting. In terms of exciting in the not necessarily quite so positive sense, because we've worked in the border space, I've ended up in the the border type narcotics, explosives, chemical weapons, some of that sort of stuff. So that gets the inciting and the not quite so interesting. I remember saying, hey, I'd like to demonstrate that we can see this explosive. And a guy turned up with a 1 pound block of it. That wasn't what I meant, but...
That is very exciting. Cool, yep. How long does it take to manufacture one device? An additional question on top of that is how big is this final device too?
Okay, so yeah, actually, I showed you. I went. So the boxes are currently about the size of a big washing machine, and it takes us, depending on what so to actually put the instrument together and get it running is the order of like probably a week's worth of work to get it all the way up to operating properly. There's then some tuning on top of that customizes it for various different customers. So typically the cycle time for an instrument going in the factory and then out the door is on the order of 1 to 2 months to go through.
Mm-hmm. Awesome. I think we only probably, because we're running quite behind still, we will give time for 2 more questions. So please vote so we can ensure those 2 questions are what everyone wants. Okay. So when is any plans to take the knowledge you've acquired and implement it in consumer grade products or more commonly available products?
So not for Syft. I think, as I said, I think we're a bit of we are a technology first company. We tend to we know what we do well in that technology. we have worked with people who have turned it into sensors. So we've helped people produce things like what they call a BTEX sensor: benzene, toluene, xylene, ethylbenzene. Those are some of the carcinogenic aromatic compounds. We help them produce their sensor. We help them validate their process. But ourselves going out and doing it's not what we're aiming for.
And last question, when is the tech small feasible enough to be used to sniff illegal drug use in the public? If that is not a stupid question.
It's not a stupid question. It's a complicated question, is possibly the best answer to it. At the moment, there are various people that have tech that they say can pick up illegal drug use. There is also various tech that can pick up illegal drugs from surfaces. There is very little that can do it in the gas phase because a lot of those drugs don't end up in the gas phase. So that's not on our roadmap at the moment. It's not something we're aiming towards, but there are people out there trying to do that sort of stuff. And I think there will be successful, but a lot of these things, and especially with people, you end up finding not the drug itself, but the effects. So it changes your metabolism, and you see chemicals come out as a result of that, so that's what happens a lot in the medical space, and I imagine might be what happens in the illicit drug space as well.
Oh, awesome. Thank you very much, Daniel, for telling us all about Syft and for answering all those questions.
No problem.
Oh yes, and also this is our little watch party in Queenstown. They're literally in the workshop, like there's like a surfboard, a car, and like a jet boat, I think. Okay, pitches.
Kia ora koutou, ko Jake Gamble Tukuingwe. So I'm CEO of Syft Technologies. So we're a new startup on the block based here in Christchurch, and we're creating a novel insulin pump for people with diabetes. So we're about to close our first round of funding. Exciting, celebrating. But now is the actual fun side of building the team. So that's part of my ask today, and we're looking for some pretty cool, motivated engineers that we'll be looking at. So around the mechanical, some pretty much everywhere. I mean, we've come out of research. We want people that know industry, know med tech, know what they're doing. It's a pretty cool mission that we're on in improving equity of access to diabetes care. You get the best tech that you only see uptake with the best insurance in the US with the best endocrinologist care, and we're on a mission to give that to everybody. So in the last 10 seconds, if you or anyone you know, please come chat. It's exciting.
Yeah.
Thank you.
Hello. This will be the same, but a bit different. My name's David. I run the Asteria Engineering Consultancy. We make high-performance electronics primarily for the aerospace industry and other weird environments. We recently developed the electronics for the first New Zealand payload to go to the International Space Station, and we've also developed the electronics for the second one that's going early next year.
Awesome.
And we need to grow our team. So a bit like him, if that sounds like a bit of you or a bit of one of your friends, come talk to me or tell them to. I'm easy to find on LinkedIn or in person. Just come find me. Thanks.
Hi, so slightly different from the past two, but related to our first two speakers. When it comes to manufacturing, we need community, which I'm actually here representing Make NZ, which is a manufacturers association. We hold events like this, we do site visits, but our main focus is just actually getting manufacturers to connect and learn from each other, whether that's their mistakes, their wins, and anything in between, really. And, well, I've got a hell of a lot of time.
Well, do you have how can they find out about it?
Well, they can find us at makenz.org. You also might have heard of us in the past. We have been known as the NZMEA and the Canterbury Manufacturers Association. We've been going since the 1800s. So there's a lot of history there. And, we just really want to help support manufacturing. So you can check out the website or feel free to come and have a chat. Thanks.
Thanks.
Hi all, I am Tilanga.
You sit down.
So
That's right.
yeah,
Thanks.
in my case, I am developing a new startup, like it is a parking concept. So I started this in one of the competition at University of Canterbury. So it is like trying to solve parking problem by using people's participation in the city. So it's a platform where people can share their driveway and pool that parking space, and so that others can see it. And this solution include like mobile app and also like hardware sensors, all about hardware sensor, like which can update that occupancy real time. So recently, like biggest challenge that I had, it is my full-time job. I'm electronics engineer. I have the capabilities in electronic space and also app development. So then I stepped down from my job. So I'm to support during this transition. I'm providing solutions like IoT space. So like if anyone of you need like help with the developing proof of concept prototype for like IoT application, I'm here to help. Thank you very much.
Yeah, g'day folks. My name is Jamie. I am in electronic component distribution, but I'm particularly interested to understand FPGA users out there, or those that might be interested in FPGAs, workshops, that kind of thing. So we're kind of looking at running workshops, getting people up to speed, because there's not an awful lot of people using FPGAs. So I'm looking to change that. So yeah, give me a shout.
Good evening, everyone. My name's Jason. I am the head of engineering at Evnex. We at Evnex are in the game of charging electric vehicles. So if anyone out there is, actually maybe that's a good idea, poll of hands driving an EV tonight? Oh yeah, a few, good. So for those of you out there driving an EV, you should already have an Evnex charger. Thank you very much. If you don't, come and see me at the end, and I will get you one for the small price of. No, I'm kidding. So we're in the game of designing chargers for EVs: Nissan Leafs, Teslas, Polestars, whatever flavour you like. Build your dreams. Heard about that brand yet? BYDs. Yep. We got one at the back. Good. And so that is the game that we're in. We have kind of two product lines that we produce in the EV charging space, and we kind of have one, the first of all was in home, so if you want to be charging in your garage overnight, we have a product for you there in that space. And then also the other one is at work. So the other place that's common to top up your car is when you pull up at work, so it could be an employee perk that your employer provides to you with some free EV charging. Or it could be that you're a large-scale company with a big fleet of vehicles and you've got your staff travelling out to site often, and so your fleet of vehicles need charging, and so we can provide you a full charging setup in your sort of large-scale, staff car park, basically. We sort of solve a problem halfway between DC fast charging and really slow AC charging. So I don't know how much you know about fast charging, because most of you are petrol heads based on that little vote that we did. So basically you've got these big expensive DC fast chargers that you're going to see at your supermarkets and you're going to see at your petrol stations, for example. So they're really great for charging on the go, long travel, long trips, but they're also relatively expensive in the scheme of things. On the other end of the spectrum, you've got charging at home with your standard 3-pin plug that you would just plug into a wall socket in your garage. And the problem with that is that it's typically quite slow. Okay, and that hasn't been a big problem for all of those Nissan Leaf drivers out there, including me, because Nissan Leaf batteries up till now, certainly the Jap import ones, haven't been that big. But as we start to see vehicles increase their range, we see their battery capacity go up, and as we start to see utes and bigger vehicles come in, again the battery capacity's got to go up. And it means that the charging time starts to blow out. And so we can offer faster charging than your standard triple, 3-pin plug in the wall, and at the same sort of cheap prices that you're going to get on your home electricity rates, rather than having to charge at public DC fast chargers. There's also some extra value add, which is that we can help you charge greener. So we give you some insights into the dirtiness of the grid that you're charging from, and we can help you choose your charging times based on cleaner times. That's not such a big deal in New Zealand, but it's a pretty big deal in Australia, where the grid typically is really, really dirty at certain times. So that's kind of that space. The fundamental value prop is really speed comparison between a 3-pin plug and one of our chargers. So Bear with me, this is the marketing comparison, which requires you to do some sort of creative math, so please don't crunch too many numbers. But on an X22, one of our X22 chargers, which will charge you at 22 kilowatts, you can get sort of like a 10 times speed reduction on your, or improvement, sorry, on your 3-pin plug. Polestar 4 vehicles, if anyone's been following the news on those, they're coming out very soon. They have 110 kilowatt hour batteries. Just to give you a scale of how much that is, the average New Zealand homes use about 22 kilowatt hours roughly per day. So it's 4 to 5 days worth of whole home energy consumption in a single battery charge. So they're big. And so we can charge them significantly faster, 4 hours rather than 43 hours. No one wants to be parked for 43 hours. Hopefully that's self-explanatory. And I can already see someone doing math, so we're going to move on quickly. If you want to talk about marketing math, I'm happy to give you an introduction afterwards. So that's what Evnex does.
Cool. How do you make these chargers?
Yeah, so we are proudly NZ made. So our assembly line is here in Christchurch, 10, 20 metres from my desk. And so we also have our PCBs assembled here in Christchurch, and we have our injection moulded designs. They all come down from the North Island as well, so we're very, very proud to be NZ made. So that means that everything happens, the full assembly happens in our office here in Christchurch. I'll show you a couple of photos of that in a sec, but just to, first of all, like every hardware meetup likes a blow up, right, like of a CAD render, so I thought I'd sneak one in. So our products are not hugely complex, okay? We're there to try and make sure that we can provide a really streamlined experience for installers to install our product, for you as drivers to actually use our product. And so it means that we try and keep everything as stripped back and sort of as aesthetically pleasing as possible. So we've got usually a single PCBA that sits within our products that deals with all of our comms back to our cloud connected backend, all the charging relays set up and so on, all the comms with the vehicle as well. And then we've got basically the enclosure, including a waterproof enclosure that's the internal enclosure that helps make sure that installers don't damage stuff when they install our product in a garage at your home, for example. So that's the kind of raw guts of it. Charging cable comes out the bottom, which isn't here, and it's the thing that plugs into your car. And of course, you've got a, sort of to Brendon's point earlier about, I think, Basis's view of energy and Evnex's view of energy in the future kind of are relatively aligned, as you can imagine. And so, of course, somewhere this feeds into a distribution board somewhere, and hopefully one day that's a smart one in people's homes. So, yeah, that's what's in it. We have sort of the core of AC charging is that we don't need to do any AC-DC inverting or anything like that. So it means that we can keep our electronics relatively simple. We have to talk to the vehicles to be able to make sure that the vehicle is who it says it is, and the vehicle's allowed to request how much charging current it wants, and so on and so on. So our devices deal with that negotiation, and then basically click through a bunch of relays, supply a mains connection to the charger, to the car, sorry, and then the onboard charger inside the vehicle takes care of the rest of that journey. We supplement some of that capability with things like gobbling up extra solar diversion that you've got that's coming off of your roof PV system. So if you're exporting excess solar generation to the grid, we can match your car's charging rate to your grid export so that you can suck up all that self-generated goodness, which is really cool. Here's how they're actually made. Maybe we'll start on the right. So no, we'll start on the left actually. So yeah, we'll go to that. So this is the manufacturing line for the product that I just showed you the blow up for. It's super simple. It's really, really streamlined line. It takes us about 16 minutes to get from start to finish, boxed product ready to go. And I have to emphasize that for a company like us, half of the challenges in the product design and half of the challenges in the manufacturing, right? We've got to hit volume and we've got to hit the cost because we're in a competitive environment, and so margins are tight, and so this is actually just as much work as it is to design the product as well. So the line's relatively simple. We have PCBA test fixtures, which are not at our PCBA manufacturer. Sorry, they're in the room. They are coming soon, and so they're in-house design and all bespoke, and currently sit at our manufacturing facility here in Christchurch. And then what's a good final functional tester without some googly eyes? Like, we're actually a wee bit proud of that one. It doesn't look fantastic, but it's a heck of a lot better than the old one that tests the commercial series, which I wasn't going to show you a photo of. And that thing's fully automated. Slide a charger in, plug a charging cable into a dummy socket, and hit go. And we've got air compressors running in the background and so on. Pins drop up and down as they need to, and we do a full test cycle. Really important to us, because when we ship a product to you, to your home, for you to plug in your garage with your kids, around in the garage, for example, or your family, then we need to make sure that everything's nice and safe and up to compliance and so on. And so we do 100% testing. So that gets a fair bit of work. So that's what's in them, and that's roughly how they're made.
Awesome. What does the journey look like so far?
Yeah, this is great. I'm very pleased that it's me talking tonight rather than our CEO, because it means I get to show embarrassing photos. So that's great. This is a great, if you want to hear a good startup story, this is the one. And I feel like every good startup story has to begin with somebody moving back to their parents' house, right? So that is where Evnex begins. 2014, Ed Harvey, our founder and CEO, photographed here in his parents' living room with the fireplace behind him, first starting Evnex. He had just come off the back of a stint at Dynamic Controls, but just prior to that had worked on a final year project at uni to convert his Honda Accord to an EV, which was fun, obviously, and so found that there was kind of this gap where he didn't really have a product that would charge it, and he certainly didn't have a product that would charge it smartly, to take into consideration what's going on in the grid, and so that was sort of the sort of birth child, I guess, of Evnex. He then spent many years, and I think he'd be embarrassed to say 2014 to 2017 and 2018, but one-man band doing everything from mechanical work to electrical stuff and so on. So very first kind of prototypes in the middle here, with some off-the-shelf componentry still. The core of it was a cell-connected sort of DIN-mounted rail block of electronics that would talk to the vehicle and negotiate that charging current I talked about before, and actually make sure that we supplied the current to it. So it was very, very early. He then jumped into the Vodafone incubator that was set up here in Christchurch some years ago. That was around 2018, where he sort of brought on the first key members of the team. So it was himself, a software developer, a mechanical engineer, and an electronics engineer. So the team sort of shot from 1 to 4 really quickly. What's really cool is all 3 of those other people are still with the company today, and so we're a wee way on, and they've stuck around, which is really awesome. And then they worked on more prototypes, and one would argue the prototypes kind of got worse for a little bit there. That's a very, very heavy metal enclosure that's very square-like. Ed would say that himself, so I'm allowed to say that. And so then it really, out of the back of Vodafone, established sort of first office, and with a fresh round of investment meant that they could look at, new custom-made enclosures for the chargers. So then it lands us sort of 2019, we end up with first delivery of an actual production run that was delivered to the office. It was something like 8 or 10 units, so really tiny, but all from proper manufacturing lines and kind of all landing in the office. So it was certainly an exciting time for them. That product was kind of launched as an an everything product, a bit of commercial, bit of home. But as they sort of went through 2019, then sort of early 2020s, realised that it was really probably suited better to commercial, and so or sort of fleet charging or charging at work. And so come 2023, we launched a home residential charger, which is much thinner and sleeker and nicer to use, has all the app support you want, and all the nice glowing LEDs and all that sort of stuff that comes with it. And so we launched that April last year, which was, I came onto the team 6 weeks before launch, so that was a little crazy, but that was a great time. And we also then pushed into Australia. That was the first time we shipped product over to Australia. I'll talk a little bit about what I need from the audience later, but pushing to Australia sounds easy, but it's actually hard. So I've got a wee ask around that a little later on. And then fast forward to today, we're a team of sort of 35-ish. I keep losing count because every week we keep recruiting people. So it could be 40, I really don't know. We have about 5 or 6 staff across in Australia, predominantly sales and marketing staff. And then the rest of us there are down here in Christchurch dealing with engineering, finance, NZ sales, installation, which is a service that we offer, and production as well. Cool. So that's the journey. Yeah, awesome. 10 years of hard work. Yeah.
What is the future shaping up to look like then? Oh, what is the future shaping up to look like? So you mentioned you just released those at residential chargers.
Mm-hmm. Mm-hmm. Yeah, so the future for EV charging, I think, in many ways is trying to figure out, it's a little bit of a betting game figuring out who's going to charge where, right? So we talked about charging at work and charging at home, this trend of getting bigger batteries the longer the range of the vehicle gets. So there are a few things that play into that. One of them that Brendon's already talked a little bit about is that actually the more energy that a car sort of consumes, the bigger impact it's going to have on the grid. And likewise, it can also add value to the grid if we had a bidirectional charger in place that allows you to discharge your vehicle and actually provide energy back to the home or potentially all the way back to the grid. It's sort of a little bit out there about whether that's going to land and whether people are going to pay for it. And I think maybe a little bit to Daniel's point, it's a little bit like the technology's kind of there, but does it have a market and an application? We're not quite sure yet. But it's certainly a natural technology progression for us. And so that's an area that we've been sort of loosely investigating and we'll be pressing into in the next wee while. So that bidirectional, you'll hear terms like vehicle to load, vehicle to home, vehicle to grid. All of these types of things are all sort of different versions of each other, but that's definitely one of the landscapes. And then the other one, like I said, is like shipping product to Australia isn't just as easy as chucking it on a ship and getting it over there. The target audience there is still different to the New Zealand audience. There's a lot higher penetration of normal PV solar generation on a roof in Aussie. And so it means that our feature set for Australia is a little bit different than it is for New Zealand. So there's a surprising amount of software development effort and hardware tweaks and algorithms that need to be changed to kind of bespoke tune all of our products for the Australian market, which has definitely been the last sort of 6 to 12 months and probably will still be for the next 1 to 2 years as well. Yeah.
And is there anything you need from the audience today?
Yeah, good question. So as I said, I think one of the things that's hard about moving to Australia, you would assume it's easy, both countries sort of speak English and the currencies are not that different, but it's just different because I was informed this week that there are 6 states and 2 territories in Australia. I made a mistake there, don't tell an Aussie that. And so there's actually like the regulatory landscape, the standardization in each of those regions, how they all think about what the future of grid supply for EV charging or home energy management, etc. All of that is just different flavors, and it's so early that it's not yet been kind of pulled together into 2 or 3 different approaches. And so it's just all over the show. And so what it means is that we've got to kind of bespoke develop things for certain states, for example, and so on. And so I guess my ask is like, if you are familiar with that problem, I don't need solutions, but if you're familiar with that problem, either that you're about to face it or have already faced it, then I'd be really keen to chat. I think we should be talking more about that for NZ companies, particularly if they need Australia as part of their kind of growth and expansion plan. So I'd be definitely keen to talk with anyone in that space. I do have a role open, so you should go and look on all the sites and find that. Other than that, just to triple echo the points that have been made already, I think there's huge value in events like this and in sharing kind of our combined knowledge and definitely mistakes and failings. And so, like I would just say open door. Like I'm on LinkedIn and I'm not on Instagram, but I am on LinkedIn. So, reach out if you have any questions or want advice, and it'd be awesome. Yeah.
Sweet. Thank you so much. Now we open to questions. Yay, please vote. Please add more questions. And try not to delete them too early, please, David. Get a bit trigger happy with that. What is the benefits and challenges of building in New Zealand? Yeah,
good question. I think the it's sort of a blessing and a curse, right? So I think one of the blessings is that it allows us to move faster because everything's close. So it means when we have a production problem, I can walk over and look at it, or it means that someone in my team can go over and address the problem, and we can patch the test fixture, we can buy the parts at the local shop, and we can go and fix it. So you get that kind of quick turnaround feedback loop. And so particularly if you're kind of pre-big manufacturing volumes and you're starting to sort of scale up, I think there's value in having proximity. And so generally the closer the better. If they're going to be in the North Island, you may as well have them in your back door kind of thing, like in your office. So so I think that's a real blessing. I think there's a downside to that, which is that there are times then where that becomes sort of an easy out, and it means that you don't necessarily get forced up front to think through all of the challenges that you're going to have at volume. And it means that your production instructions and your test fixture capabilities don't have to be bulletproof because somebody who's 10,000 miles away is the person operating it. So it's kind of, you can leverage that for the value that you get from it, being fast and being able to turn things around quickly, but the downside is maybe that you don't stop and kind of do things to the kind of, the scale bar that you maybe should. So I think that's kind of the tension between those two. Yeah.
Awesome.
Yeah.
Do you guys struggle with volume, to produce significant volume, just in Christchurch?
No, we don't. We aren't doing massive volumes like we were probably talking about, hundreds to thousands of charges over a kind of 3-month period, for example, in sales. So we're not doing crazy volumes. We don't have, the production line is simple, so we don't have any limitations in that space there. And I think our local manufacturers for PCBAs and so on have massive volume capabilities. So I don't think we're anywhere near hitting that limit. Maybe a different device if you're looking at massive volume straight out the gate. Maybe that's a different equation. But yeah, for us, it's plenty enough. Yeah.
Cool.
Yeah.
How do you manage to compete with the big players like Schneider and BYD?
Yeah, good question. I'm just going to hop back to that last one and say one other thing, which is being manufactured in New Zealand means that we are labelled as NZ made, and we very much rely on that piece. So local manufacturing means we get to lean on that from a marketing point of view. We find that has pretty good brand trust within New Zealand and has helped with our uptake, I would say. We have roughly about a 25% market share in New Zealand for charging, which we think is great given that we've got big players like Tesla involved. So that's a really good thing. So I just would say don't discount the value of that, particularly in our local NZAU markets. NZ Made is a relatively trusted thing, and I think that's worth kind of leaning on. How do we compete with big players, Schneider, BYD, etc.? So it's a good question. So the short story for us has been that we've honed in on home charging as where we think we can add value. So maybe the first part of the question is don't try and do everything because you'll probably lose. So we've tried to hone in on the home charging experience in particular to focus our effort. We think we then try and be best in that game by providing best charging experience. The fundamental is that you get home, you've had a long day at work, you want to plug your car in, and then you want to get up in the morning and you want to have enough range to get to work, right? So you want that kind of reliability, that trust in it, you want it super streamlined, and you just want to kind of set and forget it. And so we focus on trying to streamline that charging, kind of home charging experience as much as possible. We find that the Schneiders, the ABBs, the etc. tend to be more in the commercial side of things, and they tend to be kind of in with your installers, and your electrical specifiers. The charging experience is usually not as great, but also sometimes if you're using it once at a mall, you don't really mind. Now BYD, I will extend that to automakers. That's a different game, and that's a real risk for us. And so we keep a really close eye on what they're up to and how we think we can play. One of the ways we've sort of defended against that in New Zealand is that we're the recommended, the partnered charging supplier for almost every EV charging brand in New Zealand, with the exception of Tesla. And so that means that we often, sometimes you'll get a free charger with a Skoda, for example, or we'll be the default option for when you go to buy one new. And so we've taken that approach to try and kind of put that wedge in. I think that answers that one.
Definitely does.
Yeah.
Cool. Faster charging, is there any impact on battery life?
Yes. More so on older battery technologies than there are on newer battery technologies. So LFP batteries, for example, don't mind so much to slightly different answer to the question, but they don't mind so much going to full depth of discharge. They don't mind going all the way up to 100 and going all the way down to very, very low. Whereas early stage, anyone who drives a very early stage Nissan Leaf Japanese imports knows that fast charging is going to kill your battery and you're going to have about 40 k's of range in about 3 years. So, sorry if you are that person, buy a new one. So we are faster, but nowhere near as fast as a DC fast charger. So that means that we're way down the end of healthy charging rates for your battery. So yeah, it's not really a big deal in our space. Yeah.
Cool. What is your percentage of sales in New Zealand versus Australia versus elsewhere?
Mm-hmm. So maybe to just talk about, we call it a fleet size, but all of our chargers are connected to our cloud backend, so we can do 24/7 diagnostics and support of any charging issue that's going on across New Zealand and Australia. Our installed fleet in New Zealand, sort of circa 5,000 chargers and about 2,000 in Australia. Not bad, given we've been there for sort of circa 12 months in Aussie. That's probably, our sort of sales split at the moment's probably more like 50-50 NZ AU, so we're kind of ramping in the AU space. NZ's had a bit of a downturn with kind of recent policy changes, general economic times, you know, people are a bit tight. Of course, you've got to own an EV before you come and get a charger. I mean, unless you just want to buy one tonight, I'm happy to sell you one. It doesn't really matter, you know. Yeah, 50-50 is the short answer.
Is this charger compatible with any EV?
No, it's a touchy subject. Today we picked up 3 brand new vehicles from dealerships here in Christchurch, brought them back to the office and tested them with our chargers under solar diversion and under a new standard that's called ISO 15118, which is kind of like advanced AC charging, I'll call it that. So hopefully that gives you a flavour for sort of a polite no, but yes. So we work really hard to maintain consistent operation with all EV brands. Now, my point is that doesn't come without its challenges. So everybody out there as an OEM implements different portions of the standards, slightly different ways. Many of you who are involved in regulatory compliance, et cetera, know that it's a black and white line, except it's completely grey. And so there are some people playing in those grey zones, and so we have to deal with those. But what we find most is that cars are mostly supported but a little bit fussy about certain things. And so what we have to do over time is change things like our solar diversion algorithm for feeding cars more and more current as your solar export ramps up. We have to change the way that works a little bit to help a new model, which is a little bit, we'd call it a little bit slow, or you know, a bit of a dumb charging car or something like that. Would be a bit rude about it in the office, but yeah, so we maintain good support for all EVs, but it doesn't come without lots of effort. Yeah.
Mm-hmm. Is there innovative power conversion technique behind?
Behind. Let's assume behind is like inside. No, there's not. And so you will see power conversion happening in your DC chargers. Okay, and so, or in a bidirectional charger, which, as we talked about, was kind of potentially Evnex's future state. So that's one of the interesting things. The device that we've talked about tonight, these chargers are actually more akin to sort of a consumer-grade electronics device than they are a sort of heavy, you know, power electronics piece of equipment. So there's some good things about that. Like, they're not as complex and as expensive, so it doesn't hit your bank balance too much when you want to go and buy one. The downside is that it means it's more difficult to kind of, it's easier entry, let's call it that, for other players. And so we find that it's a very competitive space. And so it means that price pressure, and it means that, you know, performance and usability, all those sorts of things have to be really focused on. So, yeah.
Are there any standards emerging in domestic grid power management that go beyond the ripple control we have now?
Oh, yes. So, Australia is a really interesting territory for this. There's a lot that could be said about this, so whoever asked it, if you're here, please come see me after. Particularly in Australia at the moment, we're dealing with different states creating different rules about how much energy you can draw from the grid. They're ultimately panicked because a long time ago, someone did the math on your home only consuming about 4 or 5 kilowatt hours at any particular time. And they did that across, you know, a transformer, and then across a city, and then across a state, right? And so now everyone's going, hold on a minute, you could charge your car at 7.4 kilowatts, or you could charge your car at 22 kilowatts. Like, that's going to absolutely tank the grid. So we're seeing that people are starting to respond to that. some players, lines companies, etc., they're responding to that in what we'd kind of call a knee-jerk reaction. They're going to regulate hard, they're going to enforce things, they're not going to provide any benefit to the end driver. That's an approach. We're seeing other states or other lines companies, for example, or retailers be a bit more open to providing benefit back to the end driver. So you could look at somebody like Octopus Energy, for example, in the UK and kind of look at their rise over recent times. They're a good example of someone who's probably a little bit more forward-thinking and trying to provide benefits back to the homeowner or in our case, the driver. Yeah.
Awesome. Okay. Only these 2 questions.
Tonight's special deal is $9,999. How much do they cost? An E2 retails for $1,395. So you can buy one of those today on our website, instant quoting, delivered to you within 7 days. Come see me after. Genuine point, I'm in a proper competition with my head of sales in New Zealand for whether or not I can beat, some sales figures. So the engineering team has currently made 2 sales, yes. So yeah, if you can help me with those numbers, that'd be real great. I could really do with it. So $13.95 for an E2. Our commercial series charger and our X22 charger for 22 kilowatt charger is more expensive. Come and see me if you've got a 3-phase car, and you have to add install to that. T's and C's apply. No, I'm kidding. Yeah. Yes, great question. Who's selling for $700 installed? Just a test of your knowledge. Yes, good question. Good. So how are we going to compete with, the question just for everybody online was, how are we going to compete with $700 installed, which is something that a Tesla wall charger will give you. Now, they're about somewhere between $700 and $800 up front, less installation most of the time, so your install is usually on top of that. But the answer is it's tough, and particularly for Tesla owners, right? Because a Tesla owner is very much like an Apple owner, and so they're a brand person, and so that means Tesla charger comes with a Tesla car. Sorry if I offended anyone just now. How do we compete? The short answer is we need to be more price competitive. So $13.95 is on its way down. Look out for some news in that space in 2025. And so we need to be more price competitive in that space. The other thing is that Tesla chargers up till now haven't included features like solar diversion and other capabilities in that kind of what we call kind of New Zealand and Australia specific features. They're starting to catch up with that game very, very quickly. And so that means that we've got room to move in that space. So yeah, short answer, it's tough. And we need to be more price competitive to make sure we continue to win in that space. Yeah.
Awesome.
Third one, installation quality. So the other thing is that we've got come see me after and buy one. We have a certified network of installers, and so they're familiar with our product, and it means that we can offer a good installation service. So if you want a one-stop shop and you can't be bothered buying hardware, figuring out what you actually have to install, calling your Sparky who has no idea what an EV is and trying to tell them, and then trying to get them to install it, we take care of that whole journey for you as well. So you get all that included in the whole bundle.
And it's made in Christchurch.
And it's made in New Zealand. Thank you very much.
They should just hire you to sell the EVs as well at this point. You're very,
That'd be great.
very good at it.
Cool.
Awesome. Thank you very much. Thank you everyone very much for coming today. Thank you very much to all our sponsors, to the Art Centre and the Creative Technology Centre that we're in today.